Okay, in this lesson, we're going to look at the properties of logarithms. So just like there are exponent rules, there are logarithmic properties as well. So you see here there's a product property. Here was your product property for exponents. You had if you had the product of two different powers with the same base, you could combine them into one power with the same base if you added the exponents together. So here's your similar log property. If you have two logarithms with the same base being added together, that's like having one logarithm with that base where those two quantities inside the logarithm are being multiplied. So you can see they're very related to the facts that you have for exponents. So if you're better at those, that should help you remember some of these. Then there's a quotient property. You had a quotient property for exponents. If you had two powers with the same base that were being divided, you can turn that into one power with that base where the exponents were subtracted. And here you can see if you have two logarithms with the same base where the quantities are being subtracted, then you can combine them into one logarithm where they are being divided. And then you have the power property. So you had this for exponents as well. If you had a power being raised to another power, then you could multiply the two powers together. And so here you'll see if you're taking the logarithm of a power, that's the same as the exponent of the power multiplying the individual logarithm. Okay, so you can see some similarities there that will help you remember some of these properties. So we're going to use these to kind of take things apart and put them together, write things in different ways that might be useful to us in the future when we're doing different problems. So first here's an expression, log base 3 of x minus 2 times log base 3 of 7. My job is to write it, if possible, as one single log expression. It is possible because the bases are the same. So the first thing I would notice here is in the second term, 2 times log base 3 of 7, I can rewrite that as the log base 3 of 7 to the second power, according to the power property. Now, because the two logarithms have the same base but are being subtracted, according to the quotient property, this is the same as having the log base 3 of x over 7 squared. So I have here the log base 3 of x over 40 died. So again, you might just see this as kind of a silly exercise and taking things apart and putting them together. But when we're solving equations or using logs for different applications, sometimes it's useful for us to write them in a different way, and without this skill, we wouldn't be able to. So here, same thing. Part B, I have two terms that are both log base 8. They're being added, so according to the product property, I could then have log base 8 of 48 times 4 over 3. I can simplify 48 times 4 over 3 like I normally would. So this goes into here 16 times. So this gives me the log base 8 of 64. And I can calculate this logarithm. So before it had a variable in it. 49 is not a power of 3. There's some obstacles there. Here, log base 8 of 64 is something I know. 8 to the second power is 64. So log base 8 of 64 is equal to 2. Here we're kind of doing the opposite. We're going to expand it out rather than combine it together. So notice in part A we have log base 5 of 125 over x times y. So the first thing I'm going to notice is that there's a quotient there. So according to that quotient property, I can split this up into two logarithms that are being subtracted. This first logarithm, log base 5 of 125, I know is 3. I'm not totally done expanding because in the second logarithm now, the second term, I have x times y, which is a product. So according to the product property, I can expand just this part. Now that's all behind the minus sign. So I'm going to keep some parentheses here. And this will be expanded to log base 5 of x plus log base 5 of y according to that product property. This minus sign applies to both of those. So I have here 3 minus log base 5 of x minus log base 5 of y. For part B, okay, I see three quantities multiplying each other. I have a log. And remember, without the base written there, this is the common log. This is a log base 10. And inside that log, I have x squared times y squared times z to the negative 1. So don't forget what those things mean. So this is like three different products, which means I can split this up into these three different logs where I have the log of x squared plus the log of y squared plus the log of z to the negative 1 power. And now, according to my power property, each of these can be written as a product. This can be 2 times log of x plus 2 times log of y plus negative 1 times log of z. Okay, and probably more simply written, this would be 2 log of x plus 2 log of y minus log of z. And that would be my most expanded form of that expression. Okay. So remember, we would use these to manipulate. So just as we can expand these out, there is a property that allows us to change the base of the logarithms as well. So sometimes we're given problems where, like log base 3 of 8. I don't know log base 3 of 8 off the top of my head. I don't know what power of 3 equals 8. And my calculator, I would have to go into some special menus or have those special menus on there to be able to calculate log base 3 of 8. And maybe there's something they have in common that I could calculate, and we'll talk a little bit more about that in class. So there is a change of base formula, and we'll see why this works when we're looking at the next section of solving as well. So notice that it says if you have log base b of a value m, you can have that as the log of m divided by the log of b. And notice the new bases on the right side of the equation say c. You can make them whatever you want. So here we're going to calculate in our calculators. So like for part A, I don't have to type log base 9 of 111 in my calculator. I could type in my calculator log of 111. I'm using common log because I have that button right on my scientific calculator or any other calculator above that, divided by log of 9. And if I type that in correctly, I should get 2.14. And it should make sense. Even if you don't know the exact power to place on 9 to obtain 111, you should be able to figure out 9 squared is 81. 9 cubed would be a lot bigger than that, 729. So 2.14 makes sense. So the same thing here. I would do the log of 36 divided by the log of 216. Okay. And I would get 0.67. Okay. There are some things, for example, this is where it would be used differently. So 36 and 216 are both powers of 6. So you could have rewritten this as the log base 6 of 36 over the log base 6 of 216. Oops. Okay. I know the log base 6 of 36 is 2 because 6 to the second power is 36. And log base 6 of 216 is 3 because 6 to the third power is 216. So I could also obtain my value this way. So this is powerful with or without a calculator because it allows us, if we can see that both numbers are related to a certain number by power, we can figure them out. And if not, we can still use our calculator and our common logarithm to calculate the value. We're going to look at one small application problem here. Okay. So they say here you calculate the pH of a substance by doing this negative log of H+, where H+ is the concentration of hydrogen ions. Okay. So then they tell us the concentration of the hydrogen items for hydrogen ions for ammonia is 10 to the negative 11. And the concentration of the hydrogen ions for vinegar is 6.3 times 10 to the negative third. And it asks us what is the difference of the pH levels for ammonia and vinegar. So basically we want to know what is the difference. So the pH of ammonia, oops, I forgot an M in there, forgive me, minus the pH of vinegar. So my pH of my ammonia is calculated by doing according to the directions they gave this formula. So this is not something I know off the top of my head because of the mathematics. This is something that they are telling me based on their knowledge, chemistry, and I'm just going to convert it here. So here, if I plug in for this, the concentration of hydrogen ions for ammonia is 10 to the negative 11. Subtracting a negative here, I'm going to go ahead and write that as plus. And I'm going to substitute in what I know for the hydrogen ions for the vinegar is 6.3 times 10 to the negative third power. Now, you could look at this a lot of ways. Okay, because of this plus sign here, we could combine these together. Before I combine them together, I would want to take care of this negative here. So let me take care of this. So using my power property of logs, this could be included in this exponent power, which would make it log of 10 to the positive 11th power. Remember, this is 6.3 being multiplied by 10 to the negative third power. Then because of this plus, I could think of this as just one big multiplication problem. Or I could see this multiplication here and separate it out. So I think I'm going to go with that. So I'm going to have log of 10 to the 11th power, okay, plus log of 6.3 plus log of 10 to the negative third power. So why did I choose to expand it out? These logs don't have the base written, which remember means they are the common log, okay, which means they have base of 10. So right here, what is log base 10 of 10 to the 11th power? Remember what that's asking you. 10 to what power equals 10 to the 11th power? The answer there is 11. And so by that same logic, the answer here is negative 3. So I can add 11 and negative 3 and get 8. So if I wasn't allowed a calculator here, I could at least still simplify to this much. And then if I was allowed a calculator, I could calculate the log of 6.3 and add that with 8, which is equal to 8.8 as a final answer. Okay. So remember here, we're using the properties to help us manipulate problems and in the future to simplify equations.